In this lesson, we're going to go over how to write the name and the formula of acids. And the way that you're going to recognize a compound as being acidic is it's always going to start with at least one hydrogen. There are different rules for acids, so we are going to start with naming acids without oxygen. Naming acids without oxygen in the formula. If oxygen is not in the formula, we are going to start with the prefix hydro. Start with the prefix hydro. We are then going to write the anion's root word, but we are going to drop the ending. So if it's chlorine, we drop the ending and we would do chlor. And then we are going to add the suffix ic. And then we're going to add the word acid. So for example, if I had something like HCl, I can tell this is an acid because it starts with hydro. There is not an oxygen in this formula. So I'm going to start with hydro. I'm going to write the anion's root word, which is chlorine, but I'm going to drop the ending. I'm going to add IC, and then the word acid. So this would be hydrochloric acid. All right, let's try 3 more. All right, first one, HBr. Again, we do not see oxygen in the formula. We are going to start with the word hydro. We're going to write the root word minus the ending. We are going to add the suffix IC, so this becomes hydrobromic acid. Next one. So this one sometimes is tricky for students because it involves a polyatomic ion, but it does not have oxygen, so we're going to treat it the same way. We are going to start with the prefix hydro. I am going to find CN on my polyatomic ion reference sheet, and this is cyanide. I am going to drop the IDE. Cyanide becomes cyanic, hydrocyanic acid. Last one. Again, no oxygen, so it starts with hydro. For sulfur, you actually don't drop any letters. This would be hydrosulfuric acid. All right, up next. You can also have acids that have oxygen in the formula. If oxygen is in the formula, the rules are a little bit different. There is no hydro. So we are going to start by writing the root word. And we are still going to drop the ending. But the ending that we're going to add, the suffix that we're going to add, is going to depend on the polyatomic ion. So let's say the polyatomic ion ends in 8. Like sulfate, nitrate. We are going to add the suffix IC. So sulfate would be sulfuric. Nitrate becomes nitric. If the polyatomic ion ends in ITE, we're going to add the suffix OUS. And then, since it is an acid, we are going to add the word acid onto the end. So let's say I had HNO3. And if I were to look up NO3 on my polyatomic ion reference sheet, NO3 is nitrate. It ends in ATE. So I'm going to start by writing the root word for nitrate. But I am going to drop the ending. Since my polyatomic ion ends in ATE, I'm going to add IC, nitric acid. Let's say we had HNO2. If I were to look up NO2 on my polyatomic ion reference sheet, this is nitrite. It ends in ITE. So again, I'm going to start by writing the word for nitrite, but I'm going to drop the ending. Since my polyatomic ion ends in ITE, I'm going to add OUS, and this becomes nitrous acid. Okay, let's try a few examples for this. H2CO3. Let's do H2SO3. And let's do HClO. All right, first example, CO3. So we need to look up CO3. CO3 2 minus is carbonate. So I'm going to drop the ATE, and we are going to add IC. This becomes carbonic acid. Number 2, SO3. SO3 is sulfite, ITE. So now the polyatomic ion has a different ending. Anytime it ends in ITE, we're going to change it to OUS. This one is a little different because we don't drop any letters, we actually add letters. So I drop the ITE, and I'm going to add a UR, and this becomes sulfurous acid. It would be the same thing for sulfate. Sulfate would become sulfuric acid. So for the acids involving sulfur, add the UR back in. It's going to be the same thing for phosphorus. We're going to add some letters back in. If it was phosphate, it would become phosphoric. We would add the OR back in. Phosphite would be phosphorus acid. So sometimes we do have to add some letters back in. Last one, HClO. ClO is going to be hypochlorite. We keep the hypo. Don't drop that prefix hypo. The only thing that we drop is the ITE, and we add OUS, hypochlorous acid. Let's do one more. Let's do one more with phosphorus so you guys can see how that works. Let's say I had H3PO4. PO4 is phosphate. So I write the root word. I'm going to drop the ATE, but I'm going to add an OR back in first. Since it ends in ATE, the acid will end in IC. So phosphoric acid. So be careful with sulfurs. We add the UR back in. Be careful with phosphorus. We add the OR back in. All right, last up for today is we have to go the opposite way. So I gave you the formula and you guys wrote the words. Now we're going to go the opposite way. I will give you the name of the acid and you're going to write the formula. All right, first one, bromic acid. So it does not start with hydro. That means that it has to have oxygen. So I'm assuming this is going to be a polyatomic ion. It ends in IC. That means that the polyatomic ion is going to end in ATE. So bromate would become bromic. Now we need to find bromate on our polyatomic ion reference sheet. And its formula is BrO3 minus 1. So this is my anion. All acids are going to start with hydrogen. Hydrogen is in group 1. It's going to lose one valence electron and have a charge of +1. So when we write the formula, just like any other ionic compounds, the cation comes first, the anion comes second. These are ionic, so they still need to be neutral. Hydrogen is +1, bromate is -1. So I would have a 1-to-1 ratio of cations and anions needed to make a neutral compound. So my formula would be HBrO3. All right, second one. It would help if I could spell correctly. Let me make that look a little bit better. All right. It ends in OUS. Phosphorus acid, ending in OUS. That means that the polyatomic ion ends in ITE. So this would be phosphite. Phosphite is PO3, 3 minus. And again, since it's an acid, I know that the cation is going to be hydrogen. Cation always comes first. Again, they need to be neutral. So look at your charges and think about how many hydrogens I need to cancel out that -3 charge. Well, I would need 3 of them. So this would be H3PO3. Last one. It starts with hydro. So that means that it will not have oxygen in the formula. Hydro for hydrogen, fluoric for fluorine. Again, think about the ratio needed to make a neutral compound. +1, -1, 1-to-1 ratio. My formula would be HF. Typically, if it starts with hydro, it's just going to be an anion from the periodic table. Almost all of the polyatomic ions have oxygen in them. Not always. We saw that with cyanide. Cyanide is a polyatomic ion that doesn't have oxygen in it. But generally, if it starts with hydro, your anion is going to be an element on the periodic table. Most of your polyatomic ions have oxygen in them, so they will not start with hydro.